Hello everyone, welcome back to Codeverse Coders. Today we'll be starting with a new subject, operating system, where we'll be today doing the coding part. I hope we have studied about Unix operating systems in our previous classes. Now we'll be starting with coding part. Along with that, I will also be posting the theory lectures for these topics. Let's start. First of all comes your navigations and directories. How do we see your current working directory? You see it by PWD. Then when you have to list your files, ls. Long listing starts with L, so ls minus L. For hidden files, ls minus A. To enter a directory, you have to write cd and the directory. To create a directory, mkdir and the directory name. Now suppose you have to create a nested directory. So what you'll do is mkdir minus p a/b/c. To remove rmdir directory name, and tree is to display the directory hierarchy. Now, one important thing to note is that absolute path starts from this slash, forward slash, cd and your destination. Similarly, a relative path starts from a current directory, like cd of lab2 directly. Now, I am covering all the concepts irrespective of you know about Unix or you don't know Unix operating system. So don't worry if even if you don't have your concepts of Unix operating system clear, we'll cover them here. In Unix programming, we had done all of these topics like zombie processes and all. So that's separate. Here we'll be looking on the broader concept of operating systems. So this is about your absolute path and your relative path. Then comes about your file management. In file management, let's suppose you write cat write1.txt. So in this you are creating to write in a file. Similarly, if you write cat file.txt, it is used to display file. cp file a.txt and file b.txt. This is to copy the file from one to other. Move. So move. Suppose file.txt to your directory. Move old new. Now you may be asking, what is this used for? This is used for renaming any file. This is very important. This is a common question asked by examiners in Viva. In lab, when they ask, how do we rename a file using move command? Or they could say, how do you rename a file? So this is how you rename a file. rm file.txt will delete head, tail. wc file.txt will show the line, words, and characters of a file, which is file.txt here. More shows view page by page. Less shows scroll through files. File name shows the file type, and stat file name shows the detailed metadata. A very important command is wc, where output conceptually line, words, characters, and file name. So when you write wc minus l and file name, it gives you the lines. wc minus w gives words, and WC minus C will be characters. I hope this is clear. Characters, or you can say bytes. Next is searching and text processing. First is grep. Grep is mostly used to search for a word. Like you write grep, pattern, what you want to find, and then file.txt. Now search case insensitivity. If you want to search irrespective of the case, you'll write grep minus I pattern file.txt. Next is your find. Find is used to find all the .txt file. Like you mentioned, find minus name dot x. No, it is not dot asterisk. So basically, it is basically asterisk shows whatever can be behind the succeeding, like .txt. So it will look over all files like a.txt, where you have a, then b.txt. This .txt, it will be finding .txt if any file name ends with .txt at the end. Basically, .txt files are being searched for here. Which versus where is? Which bash? Where is bash? Which is used to show your executable location, whereas searches for binary, source, and manual locations. Fourth, sort. Sort is used to sort a file. Then next, unique. UNIQ. This is usually used after sorting. This is known as piping. So you first use sort file.txt and then you apply. Sixth, this is important. One is grep is also important. Cut. Cut is used to first column of CSV like cut minus D based on comma as it is a CSV file minus F1 file.csv. The assignment that we will be doing later on will also be using this form. So this is important from that aspect. Seventh, paste. Merge files column wise. Paste file 1, file 2. Eighth, it is used to convert your lowercase to uppercase. It is, I think, known as truncate, as far as I remember. So basically, write truncate, suppose lowercase to uppercase, and then file.txt. We had seen in order to create or write in a file, we always write like cat file.txt. So this is the format that we are taking in truncate also. SED command is used to replace Linux with Unix. So this is how you apply SED command. SED s/linux/unix/g file.txt. Now I thought that SED command would be unclear if I do not mention it in brief. So right now this was not enough to explain what SED really was. So basically SED in this S shows replacement, but locally the first available. Linux will be replaced by Unix. Old word and new word in file.txt. Now see the first example. Here only first occurrence substitution occurred. Second one, all occurrences due to the presence of your G, global tag. SED 5D, release fifth line. This format is used to suppress or remove the empty line. Rest you can mention these. Minus I edits the file in place, minus N suppresses octoprint, and minus C enables your extended regular expressions. Very important for pattern matching. Pattern matching. Next is your permissions. In permissions, we see format like this. But this is confusing to understand. So let's break it into minus RWX, R dash X, and R minus minus, which is R dash dash. So R means read, W means write, and X means execute. In numerical permissions, there is a numerical value associated with each of them where R is given before, W as 2, and X as 1. So mostly a code of 777 denotes the properties of read, write, X. Read, write, and execute is being given to the owner itself. So let's write it down. 777 is when you have given the owner the rights to read, write, and execute. Let's understand 755. That means that in the first case, the owner's case, you have given the read, write, execute permissions, but here 4 plus 1 is 5, so 2 is missing. That means you cannot write, but you can read and execute. Similarly, in this case, you can read and execute. Let's take another example, 7, 6, 6. So here you can read, write, execute. Here 4 plus 2, that means 1 is missing. So you can't execute it, but you can either read or write. Similarly here, also read or write. Are you able to understand? The first set, this 7, I'll explain with the help of example. A, B, C. A is representing owner. B is representing group. And C is representing others. Now you have to understand in A, there is a mix of three variables that is accounting to a certain value associated like 7 or 5 or 6. Now in order, if you have two values, let's say 7 and you have 4 to 1, how can you form 7? You have to take all of 3 or 4, 2 plus 4 plus 2 plus 1. So you know that 4 plus 2 plus 1 will be giving us 7. Now if I say I have the permission of 5, so you know that 4 plus 2 will exceed, but you need only 1, so 0 plus 1. Where you have 0, that means that permission is not granted to you. Similarly, 4 plus 2 plus 0, that means this access is not granted to you or to the others group. I hope this is clear. Now, whenever we have to give any permissions to the file, we write a command chmod. That is, change your change or modify your permissions 755. That is, your owner can read, write, execute. Your groups can read, write, read and 4 plus 1. So write no. So read and execute, and 7. Your others group can also read, write, execute. File.txt. I hope it is clear. This is your syntax. Now, in our assignment, we'll also have questions related to changing permissions. or owners only to execute permission and so on. So for that you'll use a chmod command. Now let's say in symbolic form where we write chmod u plus x. That means in the users or the owners permissions you are adding the execute permission also. So this is about symbolic form. Now understand in symbolic form, I'll explain it here. Let's say if I had written G plus X, that means add execute permission in group for group. Similarly, I could have written O plus X for others. And what if I write A plus X? This is a very important question. I want you all to check it, but I'll mention the answer somewhere in this screen only. So there, the answer I've written. Now let's move on to the next slide. Links. One is your symbolic link, one is your hard link. So let's understand the difference first. Hard link points to the same in node, whereas symbolic link points to path name. Usually cannot cross file systems, but symbolic link can cross file systems. Then after that still works if original name is deleted. But in case of symbolic link, usually it breaks if target is deleted. Like if you say I have to go from A to B, if I rename the city A, B as C, so will you be able to reach C? The delivery guy has already started his destination to B, but he does not know that the city name of B is now changed to C. So, but he is moving on this path itself to reach the location. So, this is what we mean as breaking of the path. Same in node number, whereas symbolic means you are different in node number. Next, we move on to compression. In compression, first we have TAR, tar. To create an archive, we use tar minus cvf archive.tar and directory. To extract, we just write minus xvf. Gzip is basically used to compress. Let's say we write gzip file.txt, or to produce it we write file.txt dot gz, file dot text dot gz. Next we have to decompress we use gunzip, file.txt dot gz. Then after that we have zip, where is it archive.zip to file.txt and unzip. Disk usage we have du minus h, df minus h. Du is used for disk usage of file and directories, and df is used for file system to check for basically free or unused spaces. Now there must be a doubt, what is this minus CVF? So in this you have three things. C stands for creating a new archive file. Create new archive file. Then we come to minus V. It basically shows your progress. Or we can say list the files. F is basically to specify file name. of archive. And when we check for minus x VF, the difference is a extracting content only. I hope this is clear. In gzip, we compress the file. Now here we are producing a new file named file.txt.gz. Now if you use gunzip, we basically decompress it back to the original state. Back to original. The zip utility is basically used to compress file.txt to your new folder or archive.zip. Unzip is used to extract. I'll write it extract, compress into. Now du minus h is basically minus h here shows your human readable format in form of bytes, KB, MB, GB instead of bytes. So this is basically about this slide. Next, what we have is your process concepts. Now comes the important topics. Now, in creation of a process, we use for to basically get the process ID or the PID. So you write PID underscore T is equal to 4. Fork creates a new process. After fork, parent fork returns the child's PID. Now always remember that a child's PID will be greater than 0. Fork returns 0. Error if fork returns -1. That means that a parent fork returns child PID that is greater than 0. For a child, fork returns your 0 itself. And for error, it returns -1. So basically, if it is less than 0, that means there is an error occurred. For equal to 0, it means it is a child. And for else, it is a parent. Get PID returns the current process ID. Get PPID returns parent process ID. Get PGRP means P group ID. Process group ID. Get SID is session ID. And get CWD is return your current working directory. Wait. Parent can wait for a child using the wait in bracket you can write null pointer, meaning the parent waits till one child terminates. That is if PID is greater than 0. That means there is a child there. So you wait till the child completes his work. Now why use it? First is to prevent parent from finishing before child. Helps synchronization of processes. Third, it prevents zombie processes when the child terminates. Next, wait PID. It gives your child process ID, null pointer and 0. It waits for a specific child. If suppose if 4 children are created and you work on this loop, it will wait for the specific child to execute. specific why. Similarly, zombie process is a child process that has terminated but whose parent has not yet collected its exit status from wait. Now let's say if your process ID is 0, you exit 0, else you sleep. Those 10 seconds the child can remain a zombie because the parent hasn't called wait as yet. Your child terminates, parent doesn't wait, then it's a zombie process. When we talk about multiple 4, which is important, you suppose use 4, 4, 4. The maximum processes that become 2 cube is equal to 8. Now, when there are general formula, when there are n fork calls, you get a maximum of 2 to the power n processes. I'll write it here. N fork calls give maximum of 2 raised to power n processes. Similarly, with the process that we've understood, we'll be creating 4 children using a for loop. Next, 4 children performing 4 different operations. This is an important question from a lab exam point of view, where an assignment that you'll be given 4 child. So addition, subtraction, multiplication, and division. Parent waits for all 4. Then you have to implement a for loop where children of I gets you the process ID of the children. If it's equal to 0, then I is equal to 0, 1, 2, and similarly, so on. You can perform the operations and exit at 0. And for 1 to 4, you wait for the PID of the children, null pointer 0. I hope this would be clear. Similarly, now let's understand pipe or IPC. This is extremely important. A pipe provides communication between processes where we suppose create a pipe FD array. So now this is your I write the full form also inter-process communication. So basically it is a basic operating system tool that lets separate programs or processes talk to each other. Let's say we create one for read and one for write. For a one-way pipe, we let a parent either write to the child or so on. So this will be a one-way pipe. Then you close it, you write the data, close, and similarly for your child. Now there is one analogy that we use, which is known as the tin can telephone analogy. See, in this, there is a trick one, remembering 0, 1. Let's say you have pipe FD of 0 equal to read. Think of 0 as an open mouth. Open mouth means reading. An open book, what do you do in an open book? You read the book. Similarly, for pipe FD1, it is write. Think of number 1 as a pencil. What do you do with the pencil? You write in your copy. Next. Next trick is known as your clean. Wait, I'll erase this. Clean up your hand. Go. In this, If the parent wants to talk to the child, if parent wants to talk, first, what if the parent throws away the ears? That is, parent would not be reading. Parent won't be reading at that time. And parent talks into the pencil. So write pipe FD of 1. Similarly, when the parent is done talking, the parent hangs up. When the parent is done. So you can write, but now so we'll use close. So close pipe FD of 1. Similarly, if parent is talking, child must listen. Child must listen. Therefore, child is throwing away the pencil. Child throws the pencil. That means he won't be writing anything. That is close pipe FD of 1. Now, child will basically what the child will do? He will put his ears to use. So for that, he'll read pipe FD of 0. Put ear to use. And similarly, last the child hangs up the pipe FD of like he hangs up the phone. He's done listening. Done listening. So basically, 0 stands for your input or read, and 1 stands for output or write. So this is what is your shortcut, or you can say how you can understand what is happening here. Now, next is two pipes for two-way communication. Let's say you need two pipes for this. This is a two-way communication. Always understand a conversation is always a two-way communication. Now, here also, never confuse 0 and 1 again. Like we had done earlier, 0 stands for open mouth, that means read. And 1 means pen, means you write at that time. So first is you define a pipe that says parent to child or child to parent. Which side are you choosing? Now, what is the parent's job? The parent's job is the parents wants to write to the child, and he wants his inputs. That means write child and then read using pipe 2. Therefore, the parent closes the unused mouth. Unused mouth and the unused pen of pipe 2. Similarly, in case of child, now child wants to read from the parent, right? So he closes unused pen of pipe 1 and unused mouth of 5, 2. So basically here, the child wants to read from parent, and child wants to also give his suggestion. He also wants to write to parent. So this is the basic. Why closing ends is vital here? Because it's a two-way communication. So unused ends can often cause bugs, or the program could hang forever in this case. So this is what is the concept of. I'll write this down for you. So this is what I had to explain. Parent would always like to give his suggestion or her suggestion to the child and wants to then get his suggestion. So he wants to read also. Similarly, the child would first want to get the parent suggestion and then give his suggestion. Now this is the read and write syntax. So write pipe FD1. Similarly, read for strings and for your normal in processes. Basically, pipe FD of 1 is denoting the right end of the pipe, and if of 0 shows your read end. Now this is the memory address and the size. Then after that in read you read here pipe FD of 0. Similarly address and now in case of strings you have to convert your C++ string to a C++ string to raw character pointer. Now in case of size of you can use dot length here for strings. Now, in case of reading, you read from a buffer. Buffer is a place where you store in between place. Like first you perform an operation, you keep the result into a buffer. Then, in case of the factorial pipe question here that you can attempt, this will be the flow of the question. Similarly, when we use the concept of string uppercase using pipes, first, the parent sends the string to the child. The child does the operation and sends the string back to the parent. This is how the work is done. So basically, conversion can be done through a ASCII-based approach. That is -32 or +32. Difference is always of 32 bytes. Lowercase -32 is equal to L minus 32 is equal to U. Then system executes a shell command from a C or C++ program. Example system. Suppose this is the shell command that you want to execute. So basically in case of the system, you are running the operating system command from inside the program only. Run from program. This is in case of a shell command. While the PS command here, that is your process status command. I'll write the full form for you. Process status. This lists all the currently running programs and their process IDs. These are different types like PS minus E, PID, PPID. You can understand PID means process ID, PPID means parent process ID. Then there's a nice value, terminal, real user ID, effective user ID, start time, elapsed time, CPU usage. You should know each of them in detail. So basically, the system command is like your remote control for a computer. It sends the command straight to terminal. Straight to terminal. Next comes your background process or timer. A timer where a child sleeps but the parent remains available. Suppose you get the process ID, then you check time is up, then the parent can continue. So a trick for this part is clone. So basically, this cloning machine, you activate a cloning spell using hope. Suddenly you realize that there are basically two identical versions of yourself in the room. Now both are at the exact spot, that is exact same room. Now you have to identify who is who. So for that, you check if the ID is 0, that means he is the clone, right? The clone follows the if branch. This is for the clone. It sleeps and yells. The time is up when he wakes up. Now, else is the original you. Your ID batch is a random number. That is your actual PID, right? That means here you will say I am original. Now you skip the sleeping part completely. Skip sleeping. Why do you want to sleep then? And you continue your work. Now, normally a parent must wait for a child to finish, right? Using wait PID. Now, standard waiting will force you to freeze in a place until your child is done. And you don't want to freeze. Freeze until child's done. So for that, you apply this is a trick, WNON, no hang trick. Lets you just glance over your shoulder for a split second. Glance over your shoulder over your shoulder for a split second. If the clone is still working, you'll instantly look away and keep doing your stuff. You never get blocked, never blocked, or wait. So this was a trick. I hope you find this topic easier to understand because I usually understand these concepts using tricks. Because you don't have to memorize these codes at all. If you understand the concept, if you understand the story, everything will be crystal clear. How should we prepare? Just identify the requirement, draw the process flow, and this process flow that we have already understood, keep this in mind always. These are the header files. And put the actual task in your parent or child that I had explained using a generic concept. This is a generic code. Now, this is an example question where we are talking about a countdown timer. This timer runs, the timer should run in a separate child process so that the parent process can continue. Once the specific time expires, the child should display an alert. So, this is the code. I hope now you will be able to understand and write the code. If you have any doubt, you can ask me in the comment section. But this will be the basic code where you're fetching the process ID. Then, if it is less than 0, that means your process has failed. If it is equal to 0, that means clone, sleep, and yell. So sleep, then yell. Else parent is there for you. Your parent will wait for you. So your parent is waiting for you till your result is 0. Your timer is still running. Else, if it is equal, your timer has completed. I hope this was easy. Understanding the question rather than memorizing will help you in doing or making the solution in just seconds. But there is an exam, like I have explained this part, but there's an important exam point. You don't have to memorize them. Just understand that the return value 0 means child is still running. PID means the child has finished and -1 means error. This is for your Viva. Now, these are some questions for you. One is on process management. These you can try. I have attached this solution in the slide itself. We have done this question where we had taken a for loop for I is equal to 0 to 4, and then we had done I equal to 0, addition, and so on. I hope you will be able to do this. I've written the requirements of the question also, but they may not be given to you all. Then second is on IPC and pipes. Here you have to convert to all lowercase. This also we have done. Try it on your own. Don't look at the solution that we've done. Use the concept of ASCII codes where we had done using -32. L is equal to U plus 22. Try this concept and I think you'll be able to solve this question. Now, a very likely alternate paper. I mean to say that if these questions will not come, a question like these, like you have to count the number of characters, words, or lines, these can come as a 7 marker or a 8 marker because mostly your assignments are of 20 marks or 15 marks based on whether they are internal or they are a lab test. So do these questions as homework. Because the previous two questions that I had shown you, they are already covered in the slides. These could be just, there would be a twist like you have to check whether the child has completed. And here you have to also count the number of character words and lines. Now, these are the priorities based on the question types, the probability of which are most important. Now, there are 5 programs that you need to master is the two-way pipe that I had shown you, the parent and the child one. The parent and the child read, write. Read means open mouth. Write means a pencil. 4 children. This is question number 1 that we had seen right now, that we had already covered in the slides. This 4 children problem. 4 children, or you can could get a variation also, not necessarily this. A timer question. This was also a question we've covered. File plus pipes and your zombie process. Now, what is zombie? Child exits the parent doesn't wait and so basically the child process finishes its execution here. Let's say you are the child. You finish your execution and terminate. After that, your parent fails to call wait. Okay, so your parent basically doesn't wait for you. It does not call wait or wait PID. This is a system call. Now, because the parent didn't check the child status, he's not worried only. Didn't check child status. Status. That means the child entry remains stuck. Let's understand with the help of example. You and your parent go to a circus. You go and play a game while your parent, let's say your father, goes to another tea stall to have a cup of tea. You have completed your task, you have played the game, you have won the game. Okay, you have terminated. After that, your parent drinks the tea and goes away from the carnival. You are still stuck inside the carnival because your parent had told you to stay wherever you are, even after paying the game. You are still in the same place, but the parent has left for home. This is just a situation, don't take it personally, but I just want to explain that the child remains stuck at that place because his parent told him to stay there. He did not check on his status whether he has finished his game or he's playing his game. Just he drank his tea and he went away. So these questions you can try out where there are you have to find maximum, minimum, average or sorted array, prime or not. Then you can understand this question where you have to take child, max, min, average, and results through another pipe. The child process finds the largest, smallest, and the average of the array. And he sends it to his parent through another unnamed pipe, and the child displays the result. This is also a highly exam-worthy question where you create a child process, the parent reads such a text file. Then he counts the number of vowels, consonants, digits, and special characters and sends the four counts back to the parent and displays all the four results. Here the for condition can be used. Like we had seen, 1, 2, 3, 4, four processes. Now, if I were you, I would have definitely practiced these 4 plus 2 pipes. The one is the 2 pipe problem. And one is an extension of that in text analysis, where the parent, whenever there's a parent-child two-way conversation, you always draw this diagram. Very helpful. And I had explained this template. I hope this is crystal clear now. If you are able to explain yourself, that means you have understood this concept. I hope I was successful in making the concept crystal clear. Crystal clear concept. If you have any doubts, do mention them in the comment section. I'll try answering them as soon as possible. Rest, if you like this video, do like, share, comment, and subscribe to my YouTube channel. And wait for my theory lecture, which is just after this, where I'll be covering the theory aspect. What is operating system? How do they work? What is queuing diagram? Similarly, basically the theory part, 5-state diagram, 3-state diagram. So that is also very interesting. I'll explain them with the help of stories. It's not something to mug up. It's just you're visiting to a petrol station. You're interrupting your cycle from going from Delhi to Mumbai. You refill your tank and then go back to your track from Delhi to Mumbai. I don't think so it must be clear at this time, but this is a part of your queuing diagram concept. So do like, share, comment, and subscribe to my YouTube channel. Bye bye.